Hi, in the given problem, mass of the particle which is kept initially at the origin is given as 5.75 kilogram. The component of its velocity along x-axis and y-axis initially are given as, for x-axis this is Vix, which is given as 5.00 meter per second, and for y-axis this is given as VIY is equal to minus 3.00 meter per second. Now, in the first part of the problem, we have to find the kinetic energy of particle initially, means when it is just at the origin. So, that is given by the expression half mvi square, the net velocity, the magnitude of velocity, or we can say speed at the origin. So that is found using the vector addition. Vi is equal to square root of square of Vi x plus square of Vi y. So here it becomes square of 5 plus the square of minus 3. So it comes out to be 25 plus 9, or we can say this is square root of 34 meter per second. So kinetic energy of this particle becomes half into 5.75 kilogram and square root of 35 meter per second. And finally this value comes out to be 97.8 joules. And here it becomes the answer for the first part of the problem. Now, in the second part of the problem, we have been given a time duration of 2.00 second, in which the particle covers a distance along x-axis as 8.50 meter, and along y-axis it covers the distance 5.00 meter. And we have to find the force acting on this object during this duration. So, using second equation of motion, we will find the acceleration of acting on the particle in different directions, means along x-axis and y-axis. As we know, the force is given as the product of mass and acceleration as per Newton's second law of motion. So using second equation of motion, first of all, along x-axis, it says x is equal to Vix t plus half ax t square. And as x here is 8.50 meter, Vix is 5.00 meter per second. For time, this is 2 seconds, plus half ax, which is missing, and again the square of 2. So cancelling this 2 here, we get 2ax is equal to 8.50 meter minus 10.0 meter, cancelling this second also. So it becomes minus 1.50 meter. Hence, acceleration along x-axis comes out to be minus 0.75 meter per second square. Similarly, using second equation of motion along y-axis, we get y is equal to V I y t plus half ay t square. For vi, this is minus 3.00 meter per second. For time, again, this is 2 second. Here, this second will be cancelled, plus half ay. This is missing. For time, again, 2. Cancelling this. So finally, this is 2ay is equal to, we know the value of this y, which is 5.00 meter. So here it becomes 5.00 meter plus 3.00 plus 6.00 meter. Hence, it comes out to be 6.00 meter, 11.00 meter. So finally, acceleration along y-axis is 5.50 meter per second square. So these are the two accelerations along x-axis and y-axis. Hence, we are able to find the force acting on the particle along x-axis, which is given as max. So it becomes 5.75 kilogram multiplied by minus 0.75 meter per second square. So finally it comes out to be minus 4.31 Newton. Similarly, force acting along y-axis is MAY, means 5.75 kilogram into 5.50 meter per second square. So here it comes out to be 31.6 Newton. Hence, in vector form, if we say this force acting on the particle is minus 4.31 I cap plus 31.6 J cap Newton. And here it becomes the answer for the second part of the problem. Now finally, for the third part of the problem, we have to find the final speed of this particle after 2 seconds. So this time we will use first equation of motion. Separately, first of all, along x-axis, which says Vfx, final velocity along x-axis, is equal to Vix plus axt. So it becomes 5 plus minus 0.75 multiplied by 2. So it comes out to be 5 minus 1.5 means this is 3.5 meter per second. Similarly, along y-axis, it becomes Vfy is equal to Viy plus Ayt. So this is minus 3 plus 5.5 into 2, or we can say this is minus 3 plus 11, which becomes 8.00 meter per second. So the net speed using vector addition, Vf, the final speed, comes out to be the square of Vfx plus the square of Vfy. So Vf is equal to the square root of square of 3.5 plus square of 8. So here it comes 12.25 plus 64 meter per second, or finally we can say this is 8.73 meter per second, and here it becomes the answer for the third and last part of the problem. Thank you.